If you're making a right angled triangle, the most important element to get right is really the right angle. Now, you could try using a set square or something like that to make your right angle, but the most accurate way to make it is actually using a compass. Now, the reason this works so well is because you can make a triangle very easily if you know the lengths of all three sides. And if the lengths of your three sides make what's called a Pythagorean triad, then it will automatically have a right angle in it. Now, the 3, 4, 5 triangle is probably the most famous Pythagorean triad, which is because 3 squared plus 4 squared equals 5 squared. So when we look at Pythagoras' theorem and think about numbers that could fit in here for A, B and C, a lot of the time we might choose two of the numbers to be nice round numbers and the other one will end up being some nasty decimal. With 3, 4, 5 triangles, we have exact whole integer numbers. 3 squared plus 4 squared equals 5 squared, and it works out really well. You'll find also that 5 squared plus 12 squared equals 13 squared. So the 5, 12, 13 triangle is also quite well known. There are a few other whole number Pythagorean triads, but there's not a huge number of them. So we're going to look at how to make a right angled triangle, firstly making a 3, 4, 5 one, and then we'll make another one that is actually with more awkward numbers. Now, how do you do it? Well, take your piece of paper and you're going to draw a line as the base. Now, I've chosen to make a 5 centimetre base here, so I'm going to label that line as 5 centimetres. That means my other two sides, I'll just draw it a little bit heavier there so you can see it. My other two sides need to be 3 centimetres and 4 centimetres. Now, how do you do that? Well, you set your compass. I've got a compass here set to a length of 4 centimetres and I've done that with my ruler. You place the point of your compass on one end of the line and make an arc. Now, all of the points on that curvy line that I've just made are exactly 4 centimetres from this end. I now set my compass, I've got another one here set on 3 centimetres, and I put it on the other end of my 5 centimetre line and I make another arc. Okay, now I'll bring it a bit closer so that you can see. Where those two arcs meet up is the top point of my triangle. So all I need to do now, and I'll do it in this large pen just to make it more obvious, is make a dot where they meet. Now you can take your ruler, I'm just going to go freehand here to show you how it works, and join the two ends of your line up. Now this is automatically going to be a right angle because I have a 3 centimetre side and I have a 4 centimetre side. So I've built a right angle without actually using a set square or a protractor or anything that measures angles. I've just used lengths to find it. So how do you make a right angled triangle where you don't know all of the sides? Here we're going to make one that has shorter sides of 5 and 7 centimetres. Now, what do I mean by shorter sides? I mean that I don't know the hypotenuse, but I know the other two sides that are going to be sitting at right angles to each other. Well, first thing to do is find the length of that hypotenuse. So, before you start using Pythagoras' theorem, write it down every time. A squared plus b squared equals c squared. And then think about which side is c. This has to be the hypotenuse. So if we know the two short sides, 5 and 7, they'll need to be here where the A and the B sit, and the C is the part that we're trying to find. Now, 5 squared is 25, 7 squared is 49, and all that equals C squared. At this point, I'll add these together, and that gives me, 74. So C squared is 74. I might write it the other way around at this point, because it looks sort of easier to understand like that. Now, what's the last step? Well, if I know what C squared is, then to find C, I need to take the square root of both sides. So I need the square root of 74. Now, this is not a whole number, so I'm going to take my calculator at this point and find the square root of 74. And we're working in centimetres, so the answer of 8.60232527 has way more detail than I want. It's around about 8 centimetres. I'm thinking I'll go to 1 decimal place, because to the nearest millimetre is probably going to be about right. So 8.6 centimetres to 1 dp, I've rounded it off, so I'll specify that. Now, when it comes time to making this, you can choose which side to draw first. It really doesn't matter. I think it's probably easiest to draw the longest side first, but it would work out the same no matter what. Now I'm going to do this big this time so that you can see what I'm doing, but the downside is I don't have a whiteboard compass. So I'm going to use my arm as a compass, and we'll just sort of guess the measurements to show you the technique. All right, so the first step would be to take your ruler, I'm going freehand, but you've got a ruler, and actually make your 8.6 centimetre line. Make sure it's got really nice definite ends, you know exactly where the ends are, and rule it really carefully on your ruler. Now you need to take your compass and set it to 5 centimetres. Pick a side, doesn't really matter which one, and let's just say 5 centimetres can be something like this. If you imagine sitting your compass point here, it's going to make an arc somewhere up here where all of these points are exactly 5 centimetres from that point. One of those points is also going to be exactly 7 centimetres from this point, and to find that, you'll open your compass arm out to 7 centimetres now, place the pointy end here, and draw yourself an arc which will come out here somewhere. Okay, now again, I've just gone freehand, I haven't used my compass, so I'm just explaining. So now you've found your top point. If you put your ruler on these and join them up, this would be exactly 7 centimetres because it's on the 7 centimetre arc, and this would be exactly 5 centimetres because it's on the 5 centimetre arc. Automatically this will be a right angle. Now mine doesn't look great obviously because I haven't measured anything, okay, but we're just talking about the theory of it here, and that's how it should work.